Loudness and loudness level talk about loudness level definitions, zone phone relation, power law, temporal integration, equal loudness level contours, hearing thresholds, recruitment, measurements methods, loudness exercise. We have loudness and loudness level. First, we have this hearing threshold curve with normal hearing people and with no background noise and so on from 18 to 25 years old. And it's yeah, the threshold is the value SP value that is should be sufficient to get the first reaction. Yeah, yeah, to get a response, a stimulus and a response. And for 3,500 hertz at the resonance frequency, there is the threshold is lowest because of the ear channel resonance in the ear channel. Psychophysics, physical stimuli, turns to a perceptual experience. So we have to distinguish between physics and perception. Intensity of sound and loudness. Loudness, the definition of loudness is describe the subjective perception of the strength of the sound. Danish hørestyrke is measured in zones. Loudness is measured in zones. Loudness level is measured in phones. Tone with loudness of 8 zone is twice as loud as one of 4 zones. Remark it's a perceptual, not physical intensity. Physical intensity, DSPL. Loudness versus intensity. Intensity, that's an objective measure. DP, SPL, A or C measuring, rating. Sound level meter to measure the intensity. Loudness is a subjective measure. How loud are these decibels for you? That is always an indirect measure, often defined as perceptual strength. Different ways to measure, for instance, categories or numbers. Categories could be uncomfortable loud but okay, so on, soft, very soft. Loudness rating methods. Reference. Assigned an arbitrary loudness value, for instance 100. Probe. Listener responds with number corresponding to his or her the perception of relative loudness. For instance, 50 is half the reference, 200 is a double. Loudness experiments. Okay. Yeah. You can have 20 presentations. Probe level is varied. Reference fixed at constant level. Your task is to evaluate the loudness of the probe relative to the reference. Write a number corresponding to the relative loudness you perceive. Is it 50, 200, or 200, and so on. Then we have log 2 rating. The difference in relative in decibels on the first axis and log 2 average rating on the second axis. Remember that a T decibel increase will double the loudness. So it's a way to remember it, and that means log 2. If you have log 2 axis, second axis, that means that you have a T decibel on first axis. Increase will increase from 6 to 7 in log 2, for instance. Yeah. So it's the first axis is logarithmic built on the second also. Then you get a right line with a certain what's called helming. Loudness growth measures magnitude estimation. Give a number that corresponds to the loudness of the sound. Any positive number can be used. No numerical examples is given. And categorical is uncomfortable and so on, loud, very soft, blah blah blah. So we have those two categories have strengths and also limitations. For instance, categorical meaning label soft, nice, and so on, appreciated by and useful for clinicians. Task is seen as simple and easy to understand for all types of patients. Same rates of data for all participants. How about limitations? Discrete data, how to analyze them? Steps equally big? Maybe not. Scale has boundaries, floor and ceiling effects. Many different labels used, language and cultural dependent. Then we have the absolute magnitude estimation. Strength is classical music methods, often seen as most direct and effective method. Scale has no upper boundary. Scale is continuous. How about limitations? Some explanation needed for participants, but you can use any number, 52 or 48. Oh, what does that mean? Every participant has own rating range, transformation of data needed for analysis and comparison across participants. What do the numbers mean in terms of loudness? How should clinicians use this? Loudness level. Loudness and loudness level. Loudness is a perceptual unit measured in zones that comes from a perceptual experiment. How can we relate perception of intensity to the physical intensity? Loudness level defined via a reference. So we have a physical scale in decibels, hertz, frequency or SPL, or perceptual scale units of pressure of perception, unit of perception. Definition: sound pressure level SPL of at 1000 Hz tone that sounds equally loud. So can be measured using a matching paradigm. If you use units phone. Sound pressure level SPL of a 1000 Hertz tone that sounds equally loud. Remark at 1000 Hertz, also 1 kilohertz frequency tones, the number of phones and decibels are the same. It's a way to remember it. Loudness continue from this level. Frontally incoming sound signal are pure tones, only on one frequency at a time. Binaural listening with both ears, no reflection. That would say an anechoic room. No background noise, an anechoic room. Subjects between 18 and 25 years old with normal hearing. Then we have this equal loudness curve. So you have the zerophone. So at the 1000 Hertz, it's 0 decibel. You have a 40, for instance, a 40 phone. Then at 1000 Hertz, the sound pressure level is 40. When the frequency is deviating from the 1000 Hertz for more higher frequency or lower frequency than 1000 Hertz, the decibel will change. The sound pressure level will change, but it's still a 40 phone curve. So therefore it's called an equally loudness curve. We have A and C rating. C is flat, almost flat over all frequencies, and you can say A weighting is a reversed 40 phone code if you just turn it on in the other way. Yeah. And then we have filter response in decibel. Yeah. Okay. Yes. So it makes sense to use LA weighting. On the other from fundamentals, on the other hand, the A-weighted sound pressure level is the most widely used single valued measure of sound because the A-weighted sound pressure level correlates in general much better with the subjective effect of noise than measurements of the sound pressure level with a flat frequency response. C weighting, which is essentially flat in the audible frequency range, is sometimes used in combination with A weighting because a large difference between the A weighted level and the C weighted level is a clear uh, indication of a prominent content of low frequency noise if there are big difference between A and C weighting. The result of measurements of the A and C weighted sound pressure level are denoted L index A or L index C respectively with the unit, and the unit is decibels. If no weighting filter is applied, the level is sometimes denoted L index Z. Loudness and loudness level. Loudness is a perceptual units in zones that comes from perceptual experiment again. Loudness level defined via a 1 kHz reference where phone is equal to decibel SPL. If you measure loudness ratings with a 1 kHz tone, then we can relate zones and phone. If we measure loudness rating with a 1 kHz tone, then we can relate zones and phone. It's the same number. Again, we have the physical scale axis. First axis, it could be frequencies in hertz, decibel, and SPL, or the second axis, perceptual scale, units of perception. We have the loudness curve. So, first axis, loudness level in phone is normally built up SPL and dB at 1 kHz, minus 20, 0, 20, 40, 20, 40, 60, 80, 100, and so on. And we have a Stevens power law from its straight line, and we have an arbitrary reference. One zone is equal to one phone. And then normal thresholds start from 0, loudness level 0, to about more than 100. Yeah, and the loudness in zone is so when the loudness is increasing from 10 dB from 40 to 50, for instance, then the loudness will increase by 1. That means yeah okay, as we told about before. Yeah. So we have a we have here a straight line in an yeah, a straight line here. Loudness level is of course first axis logarithmic build, and the loudness sum is logarithmic build. And the power law, Stevens power law, is a potential function. Yeah. And then we have another, as I told before, 10 dB increase corresponds to doubled loudness. From 40 to 50 means from 1 to 2, for instance, in loudness. From 40 to 60 dBs, 20 dBs increase, it goes from 1 to 4 the loudness. The loudness normal hearing, I will come back to this in the next video. That was part 1. Thank you.